Hello friends, welcome back. I'm Rikesh sir, and today we'll continue with the miscellaneous exercise of chapter number 8, that is binomial theorem. Till now we had completed till question number 3, so let's start with question 4. Question number 4. If a and b are distinct integers, prove that a minus b is a factor of a raised to n minus b raised to n whenever n is a positive integer. Okay, so we have to prove that a raised to n minus b raised to n has a factor a minus b. Okay, so let's start with a raised to n. Now see, I can rearrange and write it as a raised to n. Sorry, like this. A minus b plus b. So this will be equal to a whole raised to n. Okay, now we can use the formula of binomial theorem. This will be a, this will be, and this is n. So n c 0, a minus b raised to n, b raised to 0, so that will be 1, plus n c 1, a minus b raised to n minus 1, b raised to 1, plus n c 3, a minus b raised to n minus 2 b square, plus dot 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 dot, and the final will be n c n, a minus b raised to 0, so no need to write it down, it will be 1 into b raised to n. Okay, so this is our first step. So now see here, nc0, that will be equal to 1 a or minus b raised to n. nc1, let it be a minus b raised to n minus 1 b. nc3, let it be a minus b raised to n minus 2 b square, plus dot 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 ncn, that will be equal to 1. So this will be remaining b raised to n. Okay, here will be positive sign. So when I take on the other side a raised to n minus b raised to n. Now see, in every bracket, in every term, I can take a minus b common. Okay, here it's a minus b raised to n, so a minus b raised to n minus 1. Multiply this, a minus b raised to n minus 1 into a minus b raised to 1, so n minus 1 plus 1, a minus b raised to n, plus here remove 1 a minus b from this, so n minus 1 minus 1, n minus 2, and c1 a minus b raised to n minus 2, plus similarly nb. Okay. Similarly nc3 a minus b raised to n minus 2 minus 1, n minus 3 b square, and so on. So from every time I can take a minus b common. Now see, a raised to minus b raised to n is equal to this term where a minus b is a factor. Okay, hence a minus b is a factor of a raised to n minus b raised to n. Okay, so this was about question number 4. Just note it down. Now let's move to the next question. Question number 5. Evaluate root 3 plus root 2 whole raised to 6 minus root 3 minus root 2 raised to 6. This type of sum we are already done in exercise 8.1. What we can do first to simplify it, let's consider this as A and B. This will be A and B. Finally, we put the value of a as root 3 and b as root 2. So a plus b whole raised to 6 minus a minus b whole raised to 6. Okay, this will be equal to n6cr, okay, a raised to r, sorry, a raised to n, b raised to, sorry, 6c1, not r, 6c1, not also 1, we will start with nc0, so this will be equal to 6c0, a raised to 6, b raised to 0, plus 6c1, a raised to 5, b raised to 1, plus 6c2, a raised to 4, b square, plus 6c3, e cube, b cube, plus 6c4, a square, b raised to 4, plus 6c5, a raised to 1, b raised to 5, plus 6c6, a raised to 0, that means no need to write it down, b raised to 6. Okay, minus, and the same term, but there is minus, so alternative terms we will use negative sign before that. So 6c0 a raised to 6 minus 6c1 a raised to 5 b raised to 1 plus 6c2 a raised to 4 b square minus, sorry, minus 6c3 a cube b cube plus 6c4 a square b raised to 4 minus 6c5 a raised to 1 b raised to 5 plus 6c6 b raised to 6. As there is a negative sign, so 6c0 a raised to 6 minus 6c0 a raised to 6. Cancel. Minus minus it will be plus. The same sign, the terms having same sign will get cancelled. Now see 6c1 a raised to 5 b raised to 1 minus minus plus 6c1 a raised to 5 b raised to 5. So every time it will be twice, twice, twice. So I can take 2 common. 6c1 a raised to 5b plus 6c3 a cube b cube plus 6c5 a b raised to 5. So we go to 6c1, that will be equal to 6a raised to 5b plus 6c3, that is 6 factorial on 3 factorial, 6 minus 3, 3 factorial, 6 into 5 into 4 into 3 factorial. 3 factorial is 6 into 3 factorial. Okay, 5 was a 20. So 20 a cube b cube plus 65, that will be also again equal to 6 ab raised to 5. So in every term again I can take 2 common, so 2, and from this 2, so 4 and ab common. This will be equal to 3 a raised to 4 plus 10 a square b square plus 6b raised to 4. So this is a plus b whole raised to 6 minus a minus b whole raised to 6. So that implies root 3 plus root 2 whole raised to 6 minus root 3 minus root 2 whole raised to 6. This will be equal to 4. Instead of a, root 3. Instead of b, root 2 into 3. A raised to 4 means root 3 raised to 4. So that will be equal to 9. 10. A square, that is root 3 square 3. B square, that is root 2 square 2 plus 6. B raised to 4, that is root 2 raised to 4. That will be equal to 4. So 4 into root 3 into root 2, 4 root 6. 9 3s are 27 plus 3 to the 6 plus into 10, 60 plus 6 4s are 24. Okay, so now let's add it. 27 plus 60, that will be equal to 87. 87 plus 24, that will be equal to 112. Okay, so 1 1 2 into 4, sorry, not 112, so it will be 113. Here there is a mistake. We have taken two common, so it will be 3b square. So that will be 3 into 4, and that will be equal to 12. Okay, so 60 plus 27, 87, 87 plus 12, 99. So 99 into 4 root 6. So 99 into 4, that will be 396 root 6. So this is our answer. Clear? So this was about question number 5. Just note it down. Now let's move to the next question. Question number 6. Find the value of a square plus root of a square minus 1 whole raised to 4 plus a square minus root of a square minus 1 whole raised to 4. We'll again use the same method. Let's consider this as x and this as y. So x plus y whole raised to 4 plus x minus y whole raised to 4. This will be equal to nc0 x raised to 4 y raised to 0 plus nc1 x raised to 3 y raised to 1 plus nc2 x square y square plus nc3 x y cube plus nc4 x raised to 0, so no need to write it down, y raised to 4 plus nc0. Now again the same but negative sign in between, so alternative terms will use negative sign. The terms will be same. nc0 x raised to 4 minus nc1 x cube y raised to 1 plus nc2 x square y square minus nc3 xy cube plus nc4 y raised to 4. These terms will get cancelled. So this nc0 x raised to 4 plus nc0 x raised to 4 twice, twice, twice. So twice nc0 x raised to 4. Okay, sorry. Here actually n is 4. So everywhere I will replace it by 4. It's my mistake. 4c0 x raised to 4 plus 4c2 x square y square plus 4c4 y raised to 4. So 4c0, that will be equal to 1. So x raised to 4. 4c2, that is 4 factorial upon 2 factorial, 4 minus 2, 2 factorial. 4 into 3 into 2 factorial upon 2 factorial, that is equal to 2, 2 factorial. 1 is 2, 2 is 3 is 6. 6 x square y square plus 4c4, that is 1, that is y raised to 4. Okay, so now putting the value of x as a square plus root of a square minus 1 whole raised to 4 plus a square minus root of a square minus 1 whole raised to 4 equal to 2. X raised to 4, that means a square raised to 4, a raised to 8 plus 6. X square means a raised to 4, x raised to 4. Y square means the root of a square minus 1 and square, so a square minus 1 plus y raised to 4 means root a square minus 1 whole to the power 4, it will be a square minus 1 whole square. Okay, so this will be equal to 2 a raised to 8, 6 into a raised to 4 into a square, 6a raised to 6 minus 6 a raised to 4 plus a square minus 1 whole square. So a square square a raised to 4 minus 2ab, that is 2a square into 1 plus 1. This will be equal to a raised to 8 plus 6a raised to 6 minus 6a raised to 4 plus, so minus 5a raised to 4, okay, plus 2a square, sorry, minus 2a square plus 1. So when I multiply by 2, 2a raised to 8 plus 12a raised to 6 minus 10a raised to 4 minus 4a square plus 2. This is our answer. Okay, so that was about question number 6. So just note it down. Okay, students, so that's it for today. Thank you.